I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. May 1994. A magazine arrived in my hands that would change the direction of my career permanently. It was the German computing magazine CT issue 10 of 1994. Tucked inside was something I had never seen before, the very first Linux CD-ROM, Slackware 1. 1.2, kernel 1.0, the complete operating system on a single disk. I bought it, went straight home, and immediately wanted to erase OS2 from my 486. Long Andreas Hamberger. This is the Hamberger Report, where I cover the untold history of the operating system that runs the world. Why the urgency to escape OS2? Because OS2 was a beautiful prison. I had purchased Ball & C for an exorbitant amount of money. The compatibility was horrific. Every additional piece of software meant another expensive purchase, another licensing negotiation, another barrier between my ideas and their implementation. I was a student working on AI prototypes. I needed tools, not toll booths. Windows ran on top of OS2, adding another layer of complexity and cost. The entire stack felt designed to extract maximum revenue for minimum freedom. To understand why that CD mattered, you need to understand the landscape it emerged from. In 1991, computing was fragmented. The dominant UNIX variants Sun OS, HPUX, AIX were proprietary and bound to expensive hardware. You could not run AIX on a commodity PC. You could not compile HPUX for different processes. The operating system was welded to the machine, and both were controlled by vendors. If you were a student, you could look, but you could not touch. The IBM PC architecture, powered by the Intel 386 processor, was gaining traction. The hardware was becoming affordable. The software was not. Richard Stallman's GNU project, launched in 1983, had spent 8 years building the tools that made UNIX usable. GCC, the GNU compiler collection, Emacs, Bash, remarkable work. But the project lacked the one thing that made everything else run, the kernel, the core that manages hardware and processes. The GNU herd was supposed to fill that gap. It was architecturally ambitious, a microkernel design that Stallman believed was the right approach. And it was nowhere near ready. By 1991, it had been in development for years and could not boot a real system. UNIX existed, Andrew Tanenbaum's educational operating system. Clean, well-documented, deliberately simple, but its licensing restricted modification and redistribution. You could study it, you could not own it. Into this vacuum stepped a 21-year-old Finnish student named Linus Torvalds. On the 25th of August 1991, Torvalds posted a message to the Usenet newsgroup comp.os.minix. The post began, "Hello everybody out there using Minix. I'm doing a free operating system, just a hobby, won't be big and professional like GNU. For 386 and 486 AT clones. Just a hobby. Won't be big and professional." Unlike the academic purity of Minix or the architectural complexity of herd, Linux was pragmatic. Torvalds used a monolithic kernel, file system, device drivers, and memory management, all running in a single privileged address space. Theoretically suboptimal. Practically it worked, it was fast, it ran on hardware people actually owned. By March 1994, Linux 1.0 was released, over 170,000 lines of code. In 1992, Torvalds had relicensed the kernel under the GNU General Public License. The GPL meant that anyone who modified the kernel had to share their changes with the community. It prevented proprietary forking. It created a collaborative commons that rewarded contribution. The GPL was not just a license, it was a constitution. I formatted 2 floppy disks. The CD included a boot floppy image and a root disk image. The installation process was straightforward on paper. Boot from floppy 1, insert floppy 2 to load the root folder system, then install from the CD-ROM, except the CD-ROM would not mount. The error message was terse and unforgiving. Mount/dev/CD-ROM, unknown device. This appeared because the kernel had not been compiled with support for my specific CD-ROM hardware. In 1994, CD-ROM drives used proprietary interfaces, Sony, Mitsumi, Panasonic, each requiring specific driver support. The device file in /dev did not exist. The kernel lacked a compiled module to communicate with my hardware. The solution was obvious: recompile the kernel with the correct driver support. The cost was 28 hours. I could not touch the 486 during the compile. The disk threshed continuously, writing intermediate object files, linking libraries, assembling the final kernel image. The machine was a space heater, fan whirring, utterly consumed by the task. This was my first kernel configuration. I navigated the cryptic make config prompts, answering hundreds of questions about hardware support, follow-step options, networking protocols. I had no idea what half of them meant. I guessed. I enabled everything that seemed remotely relevant. 28 hours later, the kernel finished compiling. I rebooted, the new kernel loaded, I ran the mount command, the CD-ROM appeared. What was the first application I successfully ran after that 28-hour ordeal? GCC, the GNU compiler collection. I needed to verify that the toolchain worked, that I could compile code, that this system was truly usable for development. GCC compiled a simple Hello World program without issue. This was not just a test, it was a declaration. I now controlled the entire software stack, from the bootloader to the compiler. But there was another obstacle. I wanted to run X Windows, the graphical interface. My video card was not supported by the available drivers. The solution in 1994 was to rewrite the TGA video driver yourself. This sounds absurd in 2026, where graphics drivers install with a single click. In 1994, if your hardware was not supported, you wrote the driver. The source code was available. The documentation was sparse but sufficient. I modified the driver, recompiled, and X Windows started. This moment crystallized the power of open source. If the software does not work, fix it. You are not waiting for a vendor. You are not filing a support ticket. You have the source code. You have the compiler. You have agency. Installing LaTeX was, by comparison, a relief. For scientific writing, LaTeX is superior to every proprietary alternative. I could write my articles in plain text files, version them, compile them to beautiful PDFs. The separation of content from presentation was liberating. I moved my AI prototype software from Ball and C to GNU. The code compiled cleanly. The performance was comparable. The cost was zero. My professor's reaction: UNIX is so much better. He was right. That 28-hour kernel compile was not just a technical exercise, it was an initiation. I learned what modern CI/CD pipelines hide, the actual cost of software freedom. Every line of code in that kernel was auditable, modifiable, ownable. I was not leasing an operating system, I was building one. Before that weekend, I was a frustrated student fighting proprietary tools. After it, I understood something that has shaped every professional decision I have made since. If you control your tool chain, you control your future. If someone else controls it, they control you. Today's developers take apt install for granted. Package managers handle everything in seconds. The 28-hour compile seems absurd, a relic of a primitive era. But the question it raised has not aged at all. Do you own your software, or does it own you? In the AI era, this question is urgent. Large language models are trained on massive datasets. The weights are proprietary. The inference costs are controlled by vendors. You can use the API, but you cannot audit the model. You cannot modify it. You cannot truly own it. Open weight models like DeepSeek V3 and Mistral are changing this. They offer the same freedom that Linux offered in 1994. the ability to inspect, modify, and run your own infrastructure. The training costs are high, but the code is available. The weights are downloadable. The GPL fought for software freedom. We now need its equivalent for AI, licenses that ensure model weights and training data provenance remain open and auditable. The kernel won. The question is whether the same principles extend to what we are building now. That is what this series is about. Every episode covers the decisions, the arguments, the accidents, and the people who built the operating system that runs the world. If you enjoyed this, subscribe to the Hamberger Report. New episodes in the History of Linux series every week. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.